Welcome back everyone to another video, and here we are. The monsoons will be coming sooner or later, and the mosquitoes in my house are having a grand feast because they somehow found out that I have the sweetest blood in this whole world.
Nice.
But like I care, because I have came here to just chill and relax. So here's a quick recap. Previously we have completed list, tuples, sets, dictionaries, as well as strings. So more or less we have completed the most common data types we have in Python. And if you couldn't move on, there's nothing we can do because I'll be moving on to number systems.
Emotional damage.
Now, I know that 99.9999% of you guys, including myself, hate mathematics because we couldn't find the value of x, and never we would. Also, there is a little percentage of creatures from another planet who love this subject. They worship this subject. And they even summon king's rule in their dreams. God knows how they could do it. But we'll be learning what are number system. So, number system, it is actually a system which defines numbers in different ways so that we can represent these numbers in different forms. That's what a number system is. And we divide this number system into 4 different types. The first one in a list is decimal. The second type is octal. The third is binary. And the fourth is hexadecimal. Now, in the decimal number system, the base is 10. So it has numbers from 0 to 9. In the case of octal, it is 8 and it is from 0 to 7. Binary has a base 2, which means only 0 and 1. Hexadecimal, on the other hand, has base 16, so it is from 0 straight up to 15. Okay, now let's do some practicals because who cares about the theory? We don't like theory in our school as well. So let's talk about the binary number system. So let's say binary number system. So I'll be just using the print function. I will be not creating any kind of variable. So the first one is binary to decimal. Okay, so let me use the print function, and over here I'll be using the int function to convert any binary number to a decimal number. Now, one thing you have to keep in mind, that the int function only takes a string. It can only convert a string to an integer and not any other type. Like if you can see, it converts a number or string to an integer. Okay, and number, by number it means maybe a floating point number. Okay, not a binary or an octal. So what we need to do is we need to give a string and then 0b. Now 0b over here represents a binary number. Okay, like it is the representation of the binary number system. Okay, and then 1010, this is the binary number which we want to convert. Then you have to give a comma and give 2. Now 2 over here represents the base. Since a binary number has base 2, so we are giving base 2. And what it will do is, we have 1010. It will convert. How it will convert is, 0 over here represents the ones place, 1 over here represents the tens place, this 0 over here represents the hundredths place, and this 1 over here represents the thousands place. So what it will do is, it will multiply 2 to the power of cube, like over here, then add 0 to the power square, again add 1 into 2 to the power 1. Similarly, the last one is 0 into 2 to the power 0. Okay, the result over here will be 10. Okay, Next we have over here, we'll be converting the binary number to an octal number. We need to use the same notation, but since this is the oct function, we don't need to use a string. Okay, and if you use a string, it will throw an error. So that's how it's different. So 1010 and octal. And over here, the hex represents the hex function. 0B1010 hexadecimal. So now if you print this, see over here, this is the decimal 10, this is binary, this is the octal 12, and this one over here represents the hexadecimal A. Okay, now how it has done for octal is, you have 1010. What this do is, it first breaks this in groups of 3. 010 means 2, and you need to add 2 zeros over here to complete the octal number over here, and this one represents 1. You need to know the table for octal, for hexadecimal, only then you can do it. Okay, similarly for hexadecimal 1010, you need to break it in groups of 4, and for hexadecimal this one represents A. Like if you remember, if you have done computer science, then I think they have said this, that 1010 represents A, 1011 represents B, 1100 represents C, and 1101 represents D, 1110 represents E, and this one represents F. This also means 10, 11, 12, 13, 14, and 15. Okay, now let's move on to the octal number system, or let's say the decimal number system. Now, to convert any number from the decimal number system to, let's say, first we will be converting to the binary number system. So let's say I have 56, and to convert it, I'll be using the bin function, and this will convert to binary number. Similarly, I have the oct function, and I'll be converting the 56 to the octal number. Thirdly, I have the hex function, and I'll be converting it to the hexadecimal. Okay, and how this is done is, suppose you have 56. If you want to convert it to, let's say, the binary number, you need to divide it by 2. You need to continue divide it. Like, let's say 2 into 28 gives 56, the remainder over here is 0. Similarly, 2 into 14 gives 28, remainder 0. 7 gives 14, remainder 0. And this 3 gives 6, but 6 is not present, it's 7, so remainder is 1. And again 2 ones are 2, 1 is remaining, so 1, and again 1 is remaining over here, so 2 0 0 and 1. Now what you do is, you need to move from the bottom to the top, and the resulting binary number is this. Okay, similarly, if you want to convert from a decimal to an octal, you need to divide by 8. Again, move from bottom to top, and for hexadecimal you need to use 16, and again bottom to top. And remember, if you are getting the remainder over here, let's say 10 or maybe 11, you can't write 10 or 11. You have to use the representation I've shown before as A or B. Okay, you remember this. Now let's move on to, let's say, the octal number system. So what the octal number system does, it has 8 digits from 0 to 7, and our first task is to convert an octal number to, let's say, a binary number. So I'll be using the print function to print it. And let's say, oh, I haven't printed the before one. I don't think so. Okay, so let's first break this in groups of 3. This one over here represents binary to the other number systems, and this one represents decimal to the other number systems. As you can see over here, 111, 000, 70, 38, all cool, right? Now we are about to do, I guess, the octal, right? Yeah, octal number system. Now for octal number system, what you need to do is we need to first convert an octal number to, let's say, a binary number. So I'll be printing it, then I'll be using the bin function. And now if you want to represent an octal number, you need to use 0 O, because this represents an octal number. And if I want to say 56, it will convert this octal number to a binary number. You can't just type 56 because then it will represent a decimal number. Okay, you need to keep this in mind. Now we have done an octal to a binary. We'll be doing octal to decimal, like this. 6 base 8. Similarly, we have hexadecimal, right? And over here we're going to say octal 56. This one is binary, this one is decimal, and this one is hexadecimal. Now how this will convert: for octal 56, divide into 2 parts. Okay, each number, divide both of these numbers into 2 parts over here, like from the middle. Now each digit, we need to see for each digit. Okay, if you had 3 numbers as 786 or 786, let's say, sorry, it's not, I'm not doing any religious discrimination. What I'm trying to I've rubbed this is because 8 is not a part of the octal number. So if you're thinking I'm kind of doing any kind of religious discrimination, I'm not. Okay, so let's say 651, you divide this into 3 parts. Okay, and then you need to convert it. So let's say we have 56 over here. 6 represents, let's say it represents 110, and 5 represents 101. And then you need to add this, so 110, like this. This is the binary format. Okay, and now we need to convert this to it's very simple. For an octal to a decimal, what you do is you need to multiply 5 into, like this, like what we have done while converting a binary to a decimal. We do the same thing. The only difference is the base over here is 8, and this one will be 8 5s are 40, 46. Okay, and then over here 56 over here to an hexadecimal number. So 56 110, we will first convert it to a binary number, and 5 represents 101. Now you need to give 101, you need to combine it. After this is the crucial step. First you have 56, divide, like you have to divide each digit into groups, and then you have to find the binary number for each of those digits. After that, you need to join all those digits that you have got. After that, group in like you have to group them in 4s. So this one is a group, and since we don't have 2 numbers extra, we need to add zeros. This is another group. 1110, this represents, I guess, 14, and 14 means E, and this one represents 2, so 2E. Okay, let's run this. This one was our final one, right? So this was the binary, this was the decimal, and this one was the hexadecimal. Okay, so the last number system we have is the hexadecimal number system. So first, to convert a hexadecimal number system, let's say to a binary number, we are going to use the bin function. Now 0. After that, how you represent a hexadecimal number is using x. You don't have one, I know that.
Emotional damage.
Anyways, 0x, and then let's say 15, or let's say just 56. Now to convert, oh, I haven't given the comment, binary. Now to convert a hexadecimal to a decimal number, you need to give 0x 56 but base 16. Similarly, to convert to an octal, you need to give 0x 56. Okay, now how this will convert is, you have 56. Again, you have to just divide it. You have to say 6 in 4 digit, like in 4-bit binary number. So 6 over here, 0 1 0, yeah, and 5 over here will 0 1 0 1. Now you need to add this like this. Yeah, this is the binary number. For 56, you need to do the same thing. 16 to the 1 plus 6 into 16 to the power 0. So 16 5s are, I guess it's 80 plus 6, so 86. And over here we have 56, octal 56. Oh, sorry, hexadecimal 56, and to convert it into octal. So let's say I have 56 over here. I'll convert this first to a binary number. 0 1 1 0, and over here 0 1 0 1, and then what you do is you need to first join this 0 1 0 1 1 0, and then you need to divide in groups of 3. So 1 1 0 0 1 0, and then here is one missing, so like this, another 0. 1 1 0 is 6, 0 1 0 is, I guess it's 2, and 0 0 1 is 1, so 126. Let's see. Yeah, 86 126. That's great. Over here. Okay, so we have completed number systems. It's quite a hectic one. I know it was a little bit boring because as usual we don't like maths, but anyways, we have completed number systems. In our next video we'll be discussing about operators, the different kind of operators like arithmetic operators, relational operators, bitwise operators, and other operators we have, and we'll be learning them, we'll be discussing them. So yeah, if you like this video, then hit the like button, and if you're new to my channel, then hit the subscribe button and press the bell icon so you never miss an update, and do share with your friends as well, and I will see you next time.